Welcome back to session 2. I hope you enjoyed that video. Hope you were able to watch it. And it's an older video and the quality is so-so, but it really illustrates project. And as we review a little bit, the video and that garden show for the project, there was a definite beginning and an end. It started 3 weeks before the start date, and then it ended after the garden show concluded. It was multidisciplinary. There were people from all walks of life with different talents that contributed to getting that project done. All types of different resources, from equipment to people to plumbers and electricians to someone who was organizing everything and communicating, and different tasks that needed to be done. And it's infrequent. It's just one of those things that occurs once a year. So it was a good illustration of a project. I included this flow chart in your notes. This is just good guidance on organizing projects and designing and selecting your team, and some good words of advice as far as dividing your project into smaller teams. Smaller teams are easier to manage. So if you can have a smaller group assigned to a certain task, make sure you get commitment that they're available from start to end. Remove other responsibilities if possible. Try to get people from different areas with different skill sets so that they offset each other and support one another. And co-locate members if possible. That means bringing people from different locations if you can. Project planning starts with a project charter, and the charter establishes the initial plan for the project, the deliverables. Those are bullet points of things that need to happen, the schedule or timeline, and also the budget. A work breakdown structure, WBS, is a hierarchical list of project activities. What needs to be done when? You've probably heard the old saying, measure twice and cut once. It's kind of the same logic here. The better that you plan your project and break down what needs to be done, greater effort and that you put into this, greater likelihood your project will be successful. So this is an example of a work breakdown structure. Total budget for the project, $72,000. It's an installation project, and you see at the beginning is system design and estimated cost and what needs to happen. Then you've got preparation of data, you've got training, you've got preparation of documentation, and then you've got the actual rollout. So this breaks the project into manageable pieces and assigns budget to each of those pieces. The critical path method, CPM, and its close relative, the project evaluation and review technique, abbreviated as PERT, were developed in the 1950s and 60s at DuPont Corporation and at the U.S. Navy. Both techniques use network diagramming to graphically display and analyze projects with a few differences. Managers at DuPont were scheduling fairly predictable facilities cleaning operations, so they developed the CPM with a focus on making time-cost trade-offs using fixed task estimates. So the critical path method, the emphasis is on the most important activities. The tasks have a well-defined start and end date. They're independent. There's a sequence that is established, and then they're diagrammed. Network diagram graphically displays the activities and the interrelationships. So remember the work breakdown structure for the system installation project that we looked at earlier? This is an example of a critical path map, and it's basically a table that maps out what needs to happen and the sequence. So you've got the start, then you select system models, estimated time 9 days, and then you've got preparation of data, takes 5 days, and obviously you have to start to get to that point. Populate system data, 5 days. Immediate predecessors to populate data were SSM, select model, and prepare data, and you get the idea. So this is just a chart that diagrams the steps and the time needed to complete those steps. A few concepts and definitions for the critical path method. Critical path is the longest path of activities. Earliest start and finish is based on the predecessors and the earliest start and finish date. Latest start and finish date is without impacting successors and latest start finish date. Task slack, amount of time an activity can be delayed without impacting its successors. Forward pass, calculating the earliest start and finish dates. And backward pass, calculating the latest start and finish dates. Earliest start is the maximum earliest finish date for all predecessors of the task. Earliest finish is the earliest start plus task duration. Latest start, latest finish date minus task duration. Latest finish is minimum latest start date for all followers of the task, and task slack, latest start date minus the earliest start date, or latest finish date minus earliest finish date. Let's use the information given in Figure 15.5 to understand how to use the critical path method. The critical path is defined as the longest path or paths if there are two or more paths tied for the longest path, from the beginning node to the end node in the project. The longest path is deemed critical because, assuming all tasks are executed according to plan, the longest plan of activities will determine the final completion date for the project. Thus, if one of the tasks on the critical path is late, then the entire project will be late. The nodes and arrows colored in red in Figure 15.5 form the longest path in the network, therefore constitute the critical path. So if we follow the red arrows, that would be deemed the critical path, and if we add up all of these days in the path, we would come to 31 days. So basically it takes 31 days for our project to be completed. The data up here, earliest start, earliest finish, last start, and last finish. So let's walk through this. For PDAT to be completed, it takes 5 days. So if we start at day 0, the earliest start would be starting at 0, and the earliest finish would be 5. Now if we go down here, SSM takes 9 days. So earliest start and earliest start is 0, earliest finish is 9. SSM, if we follow the critical path to SSP takes 3 days, so 9 plus 3, if we start on 9, 12 would be the earliest finish date. And we get up to here, so this is a 12-day path. So if this took us 5 days, and this is going to take 12 days to get here, we've got 7 days of slack. So we could actually start on the 7th day, and finish, because it takes us 5 days, and finish on the 12th day, and we would still meet our time frame for when PSD is done. So that's how you kind of follow this throughout the entire diagram. When we analyze project resources, sometimes we have to make trade-offs, so it's important to check on resource availability and activity allocation. Always good if we can do something faster, better, or cheaper. Usually, when we're determining project timelines, we determine a best case, a worst case, and a most likely. Best case, if everything goes according to plan. Worst case, if we experience glitches along the way. And then usually somewhere in between is the most likely case, where it won't go exactly as planned. We'll have some glitches, but they won't be as bad as the worst case. In project planning, it's always good to do some risk analysis where you identify possible risks. So in that garden video that we watched earlier, obviously weather was a potential risk. There could be potential that certain equipment doesn't get delivered on time? Or what if certain people were not available on certain days? Those are all possible risks. Then establishing the probability of risk, the likelihood. Is this 10% risk or a 90% risk or somewhere in between? What happens? Potential impacts of the risks. What happens if it rains? What happens if the trucks show up 2 days late? And then determining plans to deal with risks, some preventative measures to hopefully curtail risks, Plan B, contingency plans, emergency funds if we run into very difficult delays, and then some time buffers to give us a little bit of slack in case we do run into some obstacles. And then selecting the best risk mitigation plan. How can we deal with potential risks based on the probability of those risks? Sometimes you get into a project and you find out you probably just need to cut your losses and kill it. And these are some bullet points that I included in your notes for when you might want to end a project. After your project has been executed, it's always good to do a post-project review. It's kind of like a debrief where you evaluate what went well, what failures, what things did you learn, what could you do better next time, and also praise certain team members who maybe went above and beyond to get the project completed. Sometimes an organization will have multiple projects going on at the same time. That's called portfolio management. You want to make sure that the projects fit with your organizational strategy, that you've got the financial resources, and also that it's feasible to complete it with the personnel and other things that you have going on in your organization. That's a brief overview of Chapter 15. Make sure you do the quiz and complete your assignment. And also, the end of course evaluation. Would really appreciate your completing that. Thank you.